today we're going to talk about this environment variable in details. We talked about actually environment variable, and so you got used to that, and also you actually use that actually in your lab. So for this lecture, I just want to give you more details. So you can call this advanced actually the knowledge about the environment variable. So we're going to explain how the environment variable works, okay? And we're going to look at it from the environment variable perspective. What are the attack surface? Okay, we look at it from a set UID perspective, and environment variable is one attack surface. Now we look at the environment variable angle and look at how would the environment variable affect all sorts of the programs. Okay. So environment variable, very simple, just the name value pair. Okay. So there's you see there's a name. Okay. And equal to value. Okay. So that's pretty much what the environment variable is about. And so each process, okay, each process when they started, and they will be provided with a set of this kind of value, name and value, okay, and so we call them the environment variable. So this is actually the way for the process to send the information to another process. Okay, when the process A create a process, how does process A convey some information to the child process? Okay, so how do they send the data? The easiest way is to pass down some value and to the child process. Okay, so that's the easiest way for the parents to send some data to the child. Okay, and we're going to look at how that works. Okay, so, and then the program can access the environment variable. Okay, so, and there's all sorts of ways to actually access that. Okay, and this is actually introduced in Unix, but actually adopted by most of the OS and Microsoft Windows. They also have the environment variable. Okay, the way how to access them are different. Okay. Now, how do we use the environment variable? Just quickly, so there are actually multiple ways to use the environment variable. Right? One way is to, when you write a program, okay, and so your main function, if your main function specify all the three arguments, okay, your main function can just specify nothing, okay, just main function. Or you can specify one or two of them, and if you want to make it complete, specify all three parameters. Okay, the first two you understand those for argument. The third one is actually for the environment variable. The environment variable is already passed down to your memory. When the process runs, it's already in there. Okay, and if you specify this in the third argument, that just makes it easy for you to access them. Okay, and they are in the array. Okay, and so in your main function, you can just easily go through this environment variable array, and you can access them. Okay. That's the one way to do that. Another way is to just use a global variable. Okay, so if you actually declare this global variable, that global variable is already defined. Okay, when you actually write a C program, if you declare this extern char star star environment variable, okay, so that is already defined when the program is loaded, and this will be pointing to the environment variable array. Okay. So now after that, you can just access this array, and you should be able to get every single environment variable. So there's these two different ways to access them. And this is the recommended way. Okay, so I will explain later on why it's better that you use that. And this one, you can only do that inside the main function, because this variable is defined inside the main function. If you want to actually pass it down to the other function, you have to pass that. But this is a global variable, and you can just access from anywhere. Okay? But there are some other reasons that I will explain later. Okay. So this is two things, and then there are other ways for you to access in one particular environment variable. This two array allows you to access everything. Okay. If you say I just want to access a variable called ph, okay. And you can use the library function called getEnv. Okay, so you can provide a name of that environment variable, and that will return the value. Okay, so you can do that, and you can do the setEnv. Okay, you can do the setEnv, and you can do the putenv, just similar to setEnv, and then you can do the unsetEnv. UnsetEnv basically delete that environment variable. Okay. So you can also use those library functions. What they do is basically they just go through the user environment variable, global variable. And from there, and they will just pick up the one that matches with the name. Okay, it's just library function. Okay, but underneath, just they're using this. Now, okay, so how do we pass environment variable? As I said, a process when it's created, okay, using the fork, okay. So it doesn't have the environment variable. Okay, so you need to actually pass it to this new process. Okay, so how do we pass it from the parent to child? When we actually execute some program in the child process, and what we do is we usually use the execve execv and to run the new programs. Okay, so the passing environment variable is down there. Okay, so this is a program. Okay, I'm running the programs here, and I use a fork, okay, to create a new process. Okay, so if you are not familiar with how the fork works, and this will look strange to you. Okay, so the fourth branch is going to be the parent branch. Okay, the second branch is going to be executed in the child. Okay, that's how the fork works. So the fork returns different value to parents and to children. Okay, so when you write a fork, and two processes are going to be created, and then the parent process is going to get the PID of the children. Okay, the process ID of the children. So it's going to be non-zero. Okay, that's why the parents will go to this branch. They're running the same code. Okay, the same code is going to be run by parent and child, and the child process is going to the fork is going to return 0. Okay. The value of fork is going to return 0 to the child process. And that's why the child process is going to go this branch. Okay? And they are running exact the same piece of code. It's just the return value of the fork is different. And that's why they go to different branch. In this example, we just exit from the parent process. Okay? So in the child process, we just want to run execv. We just want to run a command called env. And env allows us to print out the environment variable, okay, of the current process. Okay, so we just run the env, and I want to see what the result looks like. Okay, so now when I run this, I'm passing the third argument, which is array, and that array contains the environment variable. Okay. So the third argument is the environment variable. Okay? The second argument is the argument that's going to be provided to this command, whatever the command I'm running. Okay? So this is actually mapped to the second argument of the main function. Okay? If I run a new program, the env is going to have a main function. So this argv is going to be basically a map to that env's main function's second parameter. This is going to be mapped to the third parameter. That's how the environment variable is passed down to children. It's not automatic. If you don't provide anything here, if you put a none here, okay, and children is not going to have any environment variable. Okay, so in this example, what's going to be printed out? If I run this one, what's going to be printed out? Yes, so it's going to be print out this too. Okay. So in this program, I did not pass down my own environment variable to the children. Okay, and that I create a new set of array, and that I pass down. Okay, and many programs they will pass down their own environment variable. So they're going to pass down this. So instead of using env, they just pass down envp. Okay, so that will actually that the children inherit their environment variable. That's a common practice. Okay. So, but when you see that children get the environment variable from the parents, they are not automatic. That is because the parent says, I want to pass this down to you. Or I can choose to pass a new set of environment variable to you. Okay? Is this clear? Okay, now where are the environment variables stored? Okay, we talk about the environment variable. What are they stored? Okay, and this is actually the initial state of your stack. Okay, when you run a programs. Okay, And this is the stack, okay? When you run a program and your processing will have a stack, okay? So initially, and this is what a stack looks like. On the top of the stack, and that's where environment variables are stored, okay? All the strings relate to the environment variable. If you have a share equal to something, x, y, z equal to something, and they are going to be stored in here, okay? And so, and then all these strings going to be separated by the 0, okay? So /0, because that's the end of the string. So if you look into this region, and you're going to see a lot of strings in there, okay? And each one is actually basically a pair of name value, okay? So these are the stored in here. The environment, so this array, okay? So when you actually run this main function, and this environment variable argument and argc, they're going to push down to the array, to this stack, okay? And that's how the stack works. When you call a function, the argument will be pushed down to the stack. And we're going to see this more in the buffer overflow. In buffer overflow attack, we need to understand very clearly about how the stack works. So here, I just introduce a little bit. Okay, so if you don't fully understand how the stack layout works, when we get to buffer overflow, and you will be more clear. Okay, because we're going to spend more time on that. So these are the 3 arguments that is pushed down to the stack. And the environment variable array is going to point to the position here, because those are where the string are stored. Okay, environment variable, they're just a string, right? Name equal to a value. That's it. Okay, you have a lot of those name value pairs. So, and they're stored in here. Then those arrays just point to their starting point. Okay, that's why you can access them, those environment variable. And also, this global variable exactly just point to that place. Okay, so that's why you can access this global variable, and it's equivalent to access this at this point. Okay, and then there's argv. The argv arguments are also stored in here. The command line, those strings are also stored in here, and they will be actually pointed by this argv array. Okay, these are the actual 3 arguments. So these are not actually 3 arguments. So these are the 3 arguments that point and push down to the stack, and they point to their corresponding place. Okay, so argv point to this array, and envp point to this array. Okay, the actual array is stored in here. Okay, and then argc, which is the integer, and specify how many the size of the argv. Okay, and so that's where the environment variable are stored. Okay. A lot of us, actually, including myself, when we first get to learn the environment variable, we kept get confused between the environment variable and the share variable. Okay, so it took me a while to really figure out their difference, because when we use actually share variable, and sometimes they turn into environment variable, and the environment variable turns into share variable, so they interchange a lot. Okay, so that actually made it confusing which one is what. So at some point I decided I got to get to the bottom of that. Okay, and then we figured out. Now I think I figured out what is going on. So let me help you to understand the difference. Okay, it is actually quite confusing. So let me just try to first, how do I print out the environment variable in the shell? How do I print it out? My current process environment variable. How do I print it out? In the command line. Use env, right? Or print env, right? So, and initially I thought that's the case, but that's not the case. And so env, what is env? It's a command, right? When shell run a command, what does it do? It creates a child process, right? So when you type this, okay, in $, the shell prompt, you type env, the shell, which is running in a process, okay, this is a shell process. Okay, it's going to create a child process. Okay, and then inside of child process, it uses execv, and to run this /bin/env. So, and the env is going to print out this current process environment variable, right? So you will print out the environment variable, but it's not this parent process. It's like child process env. Okay, so you end up print out the environment variable for the child process. Okay, so if you want to print out actually your current process environment variable, and inside the shell, it actually turns out it's not an easy task. Okay, we thought, I've been thinking that's env, but and later on I found that was a mistake. Okay, so eventually we found a way, okay, and maybe there are many other ways. Eventually we found a way to actually to print out the environment variable of current process. Okay, we need to be able to do that to see the difference between the shell variable and the environment variable. Okay, so we end up using this string command. Okay, so environment variable is actually maintained in a virtual actually the file called /proc. Okay, and then the PID, whatever the process ID. So if you go to the /proc folder, which is a special folder, and for every process ID, okay, every running process, there's a folder in there. Okay, if you go there and you can look at it, there's a file called the environment file. This is not a real file. This is just a virtual file. Anytime you want to read from this file, and the system is going to print out the environment variable of this process ID. Okay, it's not a real file. Okay, it's just a virtual device. Okay, and so now in order to print out any environment variable of any process, you just need to know what the PID is. Okay, so we end up just using the $. $. is a special variable in the shell. It's a shell variable. It contains the current PID, the PID of the current process. Okay. So if you just type the string S means I want to read from this file. I only want to read a string. Okay. I don't want to print out the non-string. That's what the string command is. Okay. And so this one is going to actually go to that file. Okay. And because when I run this one, the shell is going to replace with the $, with actually the current PID. So I end up printing out the environment variable of the current PID. Okay, so that's how an easy way to print out the environment variable of the current process inside of a shell. Okay, in the shell prompt. Anytime you want to run a command, you will actually end up printing out the environment variable of the child process, not the current one. Okay, just keep that in mind. Okay, because sometimes and you tried something and it doesn't work, and you probably tried that in the child process. Okay. Now with this one, now I just want to I'm doing a graph. I want to look at what's the value of the log name. Okay, it says login name is a C. Okay, so and now I also echo login name, and I get the same value is C. So what is the relationship between this one and then this one? This one, I know this is the environment variable. And this one is not an environment variable. When I put a $, and this is a shell variable. Okay, the reason why they have the same value, same name, that's because when shell is executed, when you run the shell, what the shell does, it actually takes whatever in the environment variable, it converts them into a shell variable. Okay, the environment variable are still there. Okay, but it's not easy to access those environment variables. Okay, so what the shell does is actually to create a copy and for the environment variable and call it a different name. Put the same name. Sorry, use the same name. So for the environment variable login name, that's a shell variable called login name. Okay, now if I do this, I'm changing the shell variable. Okay, and then I echo this, you can see the shell variable get modified, right? Now, if you think my environment variable might get modified, these are now two different variables now. The environment variable here stored in the memory of this process, shell variable stored inside the shell program. It's only recognized by the shell. Now I do the string again, trying to get my environment variable from the process, from that region, right? I get seed. So that one is still seed. What is modified is a shell variable. So you can see these are different things. Okay. Now I unset this. Unset means I delete that environment variable. Okay. And I echo. Unset is unset is actually unset that shell variable. Okay. Shell variable. Sorry. I unset the shell variable. Okay. So, and I echo that, and that is gone. Okay, and there's nothing here. Okay, and if I do the string, this again, my environment is still there. Okay, so those commands, they just manipulate the shared variable. Okay, and these are two different things. Okay. Now, what makes this confusing at this point is fine, right? What makes this confusing is when you define a shared variable, okay, and when you actually export it, when you say export an environment variable, and this environment variable, this shared variable, you export a shared variable. You cannot export an environment variable. You export a shared variable. This variable will become the environment variable of the child process. Okay, so if you export a shared variable, then you create a new child process. You're going to find out inside of child process, this becomes an environment variable. That's because the shell decide to do that. Shell decide when it create a new process, it will pass down whatever is exported. That's what export means. It says it's going to be affect the child process, not the current process. Okay. So this is the whole process, how this environment variable and are converted from shared variable and the environment variable. So initially it was an environment variable, okay, stored in the process. When the process is created, and this is called environment variable. When the shell runs, and the shell is going to copy all the environment variable, as I said, and turns that into a shell variable. Okay, and so now inside of shell, now you can actually access those shell variable, okay, and you can do things. But whatever you do to the shell variable doesn't affect the environment variable. Okay, and these are the two copies now. And also you can define a new shell variable. You can define new one, and there are two ways to define. Either you export it, or you don't export it. If you don't export it, that means this shell variable is only affect the current shell. Okay, it's not even affect the environment. It's just a shell. Now, if you create a new process, the child process, both this one, the one that copied from the environment variable, they are automatically exported. Okay, and the one that you exported will be copied to the new process, becomes the environment variable. Okay, that's how the shell variable that you define here become the environment variable of the child. If the child is a shell, if the child is a shell, it will do the same thing. This whole thing is going to be copied to the shell variable. Okay, if the new process runs a shell, okay, it doesn't mean that new process is going to run shell program. But if it does, then all this environment variable will be copied into the shell variable. Okay, whatever you exported here is going to be the shell variable in this new process. Okay, so that's actually how these things work. Okay, and you see them actually have the same value, same name, and you can get confused. But that's exactly what happens. Okay, and you can define. There are some other predefined shell variable. Okay, and those will not be carried over to the child process because those are not. For example, like this one. This is not exported. When the shell program started, it defines its own variable. But this own variable is going to be the private copy. They will not be exported. They will not be used to affect the new process. Okay? But the one from here will be automatic, unless you delete that. Okay? So if you in here, you said, I want to delete this environment, no, this shell variable. Okay? You can do that. You can unset a shell variable. That shell variable now will not appear in the environment variable. Okay, that's how you can delete something. Okay. So here's an example that I show. And so I do the same thing. I try to print out it. I get seed. Okay, and I define this log name 2 called Alice, and I did not export it. Log 2 name 2 not exported. Log name 3 and equal to Bob exported. So I have this one. Now if I run env. And I'm going to grab this log name, I got this 2. How come? Why did I get this one? I want env. Okay? Yeah. Very good, very good. because when the env is run, it's actually run in the child process. It's going to print out its own environment variable. Now let's look at what environment variable get actually copied to the child, right? We just talked about this one get copied. This came from the original environment that automatically marked as exported. And this one is actually exported because it says exported, right? And this one is not. And that's why you only see this two, but you do not see the login name two. Okay? And that just shows you how these things work. Now if you unset this, now after I execute the env, I come back to my parent process now. Okay? So when I do the unset, I'm actually unset my current process, this login name share variable. Okay? But by unset this share variable, and you basically remove that from the list of the exported variable. If I run the child process again, and you can see this one disappeared. Okay? It was in parent's environment variable, but you unset it. You delete it from the share variable. Okay? And it doesn't affect the child process. Okay? Question? Yes.
Is it possible for once you've got a process running, is it possible to change that process's environment variable?
Yeah, sure. Those are in a variable. So in those region, right? And so you can do this using the set env and put env, unset env. You have to use those functions. Okay, this unset is a built-in shell command. It's different from the unset env. Okay, so that one only unset its own variable. But this one in the program, you write a C program. If you do this, and they basically using that global variable, and they basically go to the global variable and set the value. Okay, and remove the value. Okay, so one thing I forgot to mention is, let me go back to that picture. So initially, this would point to here, okay? This points to global variable, and this one point to the same place. And looks like they are equivalent. But think about, what if I add something to here? What if I add in my variable? What's going to happen? I may not have enough space here, right? It was initially put in here, but this was actually a lot of data in there. There's no extra space. If I add something, or if I change something in my variable, the value becomes longer. I won't be able to put everything in here. So when that happens, and the system is going to actually copy everything and to another place, okay, and usually into the heap. Okay, so all the environment variable is going to be copied into this heap place. Okay, that's dynamically allocated area, and then this environment variable is going to be pointed to the new place. But this array still points to the old one. Okay, that's once this happens, if you delete something and if you add something, if you're trying to access them from here, you will never be able to get it. Because this one still points to the old copy. But this one is always point to the new copy. So that's why if you want to access the environment variable directly, okay, instead of using those libraries, and you need to, and this is the best way to do that. Because anytime when this happens, the value will be modified. Okay, so if you don't touch this environment variable, it doesn't matter. Okay, when this run out of space, they have to copy everything. Okay, so definitely in the program you can actually make change to your own environment variable. Okay, but not through this shell command like that. Okay, in your C program you can always do that. Okay, so. Oh, your question, sorry.
If you use system to execute it, you call the shell, right? So
yes.
How is the environment variable being dealt with the system command?
Very good question. Okay, that was a question I'm supposed to ask in the help session. But let's look at it now. Okay, so yeah, so your question is we are using the system, right?
Yeah.
So we're using the system, and let's see a function, right? Whatever the command, right? So let's see what happens. Okay. So when you run a system, okay, the parent process, okay, the parent process. it's going to do what? It's going to create a child process, right? And it's going to do what? What's the child process going to do in system? We talked about that. Call the shell before that. How can they call the shell? Okay, using what? Exec V, okay? It has to use exec V, okay? So the pattern is always like this, fork. After fork, you have exec V, okay? Exec V never returns, okay? You have to, so exec V will never return. When you run exec V, it's going to actually load the binary into the current process. Right now, the current process, when you clone it, the current process still runs the shell code, not on the shell code, the parent code. Whatever the code that you have in the parent, it's going to be loaded into the child. Okay. Now, usually, if we want to run another command, we will just do the exec V. So when you run exec V here, exec V is going to load the new program. It's going to overwrite your current, actually the program, okay, for this process. So now the parent's process code is gone. It's overwritten by this new one. Okay? And so this process will never return. It will only exit. Okay? So it's unlike the function call. Exec V is not a function call. Okay? Function call, you call that, you return back. Okay? Exec V, once you call exec V, your code is gone. Okay? Whatever, when you run the call, that code is gone. Okay? So the entire new code get it brought in, and start execute from the main function. Okay? And the main function, we know when the main function returns, the process dies. Okay? So the exec V is going to be invoked. Now, what does exec V do in this case system? Run shell, right? The exec V is going to actually run the /bin shell. The parent process is probably still your C program, okay? That's your C program, not a shell program. It's run the code that you wrote. Now, when you actually get to the system, inside of system, so this system is a function call, okay? And inside of system, function call is going to create a new process, okay? And the new process is going to run this new binary, okay? Not your main function anymore, okay? And then when this finish, okay, it doesn't return, okay? System is just going to waiting for this to exit, okay? It doesn't actually waiting for you to return because you never return, okay? What system is going to just wait for end. And so when this process is exited, finished, then your system returns. Okay, so this is not just a jump back to you. Okay, just really it has to use a particular mechanism to wait for a process to finish. Okay, and then the system returns. So now this is how the process works. Now back to your question. So can you ask your question again?
What happens to the environment variables?
Okay, so now let's look at the environment variable up here, right? This process has environment variables. Now, how do we answer this question? So I want you to give it a try. This is a very nice question. So now we do the system is exec V, right? And exec V, and what happens to this environment variable? What's going to happen? Okay, remember the third argument is the environment variable. Now the question is whether this argument is passed down to this process or not, depending on inside of system. This is a function, right? Inside the function, when this function called exec V, whether the third argument is set to here, this or not. What do you think? Is set to empty or set to a new set of variable or set to the original set of variables? New set, empty set, original set. Yeah. So if you look in the source code, it actually provides this global variable. And this is actually put in here. And that is a global variable that points to the environment variable. That means I'm going to passing down my own environment variable to the child. Okay, so that's why the tricks that we played, right? We are setting an environment variable. We are setting a share variable. We are setting the share variable in the parent process, which is your shell, right? And this is actually the setuid program that we run. How come the share variable that you set in there affect that setuid program? That's what happens. Because your share program, you have to export it, right? If you don't export it, it doesn't matter. If you define, you modify the path. Path is already exported, so you don't need to export it again. So, but if this variable is not exported, now, even if you set it, it doesn't matter. Okay. Now, since this one is exported, in the parent process, we modify this environment variable. No, sorry, we modify this share variable. Okay, that share variable. Okay, and that's inside the shell, right? That's inside the bash. Okay. So inside the bash, when I type the setuid program, right? So when I run this one, okay, let's see. Okay.
Bash, you set a shell there.
Yeah, so so I'm also kind of get confused a little bit here. So what we are doing is in the parent process, right? We are setting the environment variable in the shell, right? The shell. We are setting the shell. Then what do?
And then you run the program.
We run the program. We run the setuid program here. Sorry, I made a mistake, right? Yeah. So this is very interesting to really derive how that things work. Okay. So we are our parent is a shell, right? That's we are in the shell from, right? So it has a shell variable, okay? Because right now we only work on the shell variable. So let me just write down. We are only work on the shell variable, okay? We are not even touching the environment variable of this process. Whatever we do to the path, what we call them the environment variable, those are actually the shell variable, right? Now we modify them. Okay, now let's see how this affects that setuid program. Right? At this point, now we run the, let's see the setuid program, right? This is where we type the setuid program. Okay, now setuid program is going to, a new process is going to be launched. So the shell is going to actually launch a new process. Okay, and inside of this process, the UID, EUID is equal to 0, and RUID is equal to seed. Okay, whatever the value for seed is, that becomes setuid program. Okay, now let's look at how this shell variable get into here. Right, when the bash runs the setuid program, what does it use? What does it use? How does a shell run the setuid program? Exactly, okay? So always exactly, okay? So on the third argument, okay, that's where this shell variable export shell variable are put in here. Not EMV, not the environment one, okay, not that one. So only the shell variable are put in here. And that's how the shell pass its own shell variable to the new process as the environment variable. Okay? So this whole thing now becomes the environment variable, okay, of this new process. Okay? Now from here we call the system, right? So this involves several things. And then from here, now we call the system, right? That's a vulnerable place, right? Inside this setuid program, there's a function called the system, and you use this one to run the ls minus l, right? Okay, so this one now is going to go to here. Okay, so when you run a system, it actually is going to create another process here. A new process is going to be created. Okay, and that process is going to use execv shell and to run this command. Okay, and also the third argument is actually is that global variable. That's how this environment variable, this set of environment variable becomes environment variable of this process. We have 3 processes involved, right? So the whole thing is quite complicated, right? And so in the last class, we did not actually touch upon this, right? We only see that shared variable. We even call that environment variable, and how that affects the execution here, right? The ls minus l is actually executed in this process, but you start from here, okay? You make the change to that variable, that shared variable. That's how it gets propagated eventually to the environment variable. That environment variable, and it becomes the shared variable, okay? Because inside we run the shell, okay? So whatever they get into here, it turns into the shell variable again. Share is going to run this one. Share is going to be affected by that path that we set right in here, okay? So I hope this is complicated, but I hope now you understand how the environment variable works, and you can derive this. Okay, I didn't derive this before the class. Okay, that's why I thank you for the question. But I understand how that works, so I should be able to derive this. I hope you can do the same thing. Okay, so in security, and you can't just remember everything. Okay, and you have to just remember the fundamental part, and when this comes up, and you can actually do the derivation, just like the math. Right? You cannot remember the answer for all the mathematical questions. But if you have the skill to derive that, and that's very important. Okay? Okay, that's complicated. Okay, so now let's look at if I from the environment variable perspective, okay? So and we have the attack surface. Okay, how would people attack you? Okay, and through the environment variable. Okay, so and due to the time concern, I will not actually ask you to do the exercise. So I will just directly go to this. So let's look at environment variable. How environment variable affect the program? Okay, so how can a variable affect the program? Okay, what is that critical? So you got a variable, and that variable is stored in the memory, right? When I run a process, so in this process, we know this environment variable is stored in here. But how would that affect the behavior of the program? How? Would that matter because it's in the memory?
Program uses the variable.
Okay, very good. You gotta use it, okay? You gotta use it, otherwise it's not gonna affect you. Okay? So those variables have to be used by your program. The question is, your program may not use it. But somebody somewhere in your program uses it. Okay? That makes it so interesting, so difficult. So you write your own code, right? Your main function, right? And you only have a few lines of code, right? And you said, I never use any of my variable in this code, right? I'm just calling some function, I call something, but how come I got all this attack surface? Okay? It's because it looks like to you, it's just that your code is here. But that's not how it works. Okay? This code, when this code is loaded into the memory to be executed, a lot of things happens. Okay? So a lot of other code get executed. Okay? And that code, if they use the environment variable, and they can be affected. Okay? So these are all the places where you may not be aware of. So you write your own code. Inside your application code, you use it. As long as you use it, you got an attack surface. That one we clearly understand. Now, if you use library, right? You use library, right? What if that library uses an environment variable, right? It could happen. What if you use the environment variable? Then I'm not using it, but that library uses it. And I don't even know they use it. Right? That becomes the issue. Okay? So that happens. I will give you an example. What if I use an external program? And that external program uses environment variable. I'm not using it, but that external program uses it. Right? We had an example here. So give me that example. Give me back to the example. This case. A program doesn't use the environment variable itself, but it calls an external program that
Except
That system, that's exact system, not exact V, okay? The system, okay? That is where this system right? If you use exact V, you're okay, because exact V doesn't call an external function, okay? But if you use a system, the system called the /bin shell, this external program uses inline variable. So that becomes a part of my problem, because it's running in my process, okay? And all the inline variable in my process is going to affect the behavior of this. So that becomes an attack surface. So we understand that. So we're going to just look at these two cases, okay? So we actually look at these cases, but how come? Why would that happen? Okay. So we talked about the dynamic link library, right? How would that affect? And also talk about the setuid fix that problem, okay? And I hope that in your lab, then you actually reach that conclusion, okay, from your observation. So here's my experiment. So I just tried this. I'm just trying using. I'm copy this env to my own function, to my own file called myenv, identical program. I turn this into setuid program owned by root, okay? And that's why you can see that's S. Whenever you see this S, okay, that means become setuid program. And in your terminal, this will become red, okay? So this becomes, but this is the identical copy of that program, except this one is on the setuid bit is on. That's only different. Now I'm export in my shell. I'm exporting these three variables: preload, library path, and I also put another one my own. Okay, I have these three. I run env. Okay, the non-setuid one. Now I grab anything started with ld underscore. I get it three. I get all of them, right? That's expected because I exported them when I run env. They should print that out for the normal program. Now I run my env. Remember, my env is identical copy of the env, code-wise. Okay, but you can see I only get one value. The first two is not actually even in the inline variable. So how come?
It's protected.
It's protected. Yeah.
You cannot export it and change it.
System. So I can export it. I can export it. What happens is, yes, what happens when the system runs exec v, okay? So when it realizes the real UID and effect UID are different, and they will remove all these important critical inline variable, the one that they understand are critical to the system security. So these two are removed from the list, okay? And this one is not on their blacklist, okay? So this one is allowed. And that's why you can see this one is printed out, but the other two got removed. That is because when the system load the process and do the exact V, and they will actually inspect the inline variable, remove the dangerous one. Okay? Only for setuid program. Okay? If I'm running env as a root, if I'm in the root account, I'm running env, what's going to be printed out? 3 or 1? 3. I'm running as a root privilege. Right? Still 3, okay? Because they look at RUID and EUID, whether they are the same. If they are the same, then that means root is running that. Okay? Not the normal user running root program. And that should be okay. The root want this inline variable to be passed down to the child. Let them do that. Okay? But only when you run a normal user run a privilege code, and that becomes dangerous. Because that is you escalate the privilege. Okay? And that's when you need to be very careful. Okay? So how come this so what make this happen? So when actually when you write a program, that program, let's see, it becomes the binary. Okay, so actually inside your binary, what is the engine point of your program? What is the engine point? When your program gets loaded, what engine point means the first piece of code that will be executed. What's the engine point? It's a main function, which is not right. Okay. That's true. So your function, your code started with main, but the compiler linker adds a piece of code to your code. Okay, so the main entrance, the entrance is the loader, the linker library, and that will be the ld.so or ld linux.so. And for all this, the binary of this particular format, the most common format, and this code, the code in that library will be executed. Okay, that's for the linker. The job of this one is to link your library, or the dynamic link library, like printf. If you call the printf, it will link that printf with actually the real code, because your code doesn't contain the code for printf. Okay, without this linker, if you just directly jump to main, your program won't run, because when you use the printf, where's printf? Right? You haven't connected yet. So before your code can run, and this one will run. That's why your binary, your engine point is here. Once your binary is loaded into the memory, the system will actually jump to here to run your code. Okay. After this finish, it now will go to your main function. And this code is running in your privilege, okay? That is running in your process. That's after process is created, after UID is set. Okay? If this process if this code use environment variable, it will be affected, right? The behavior of this will be affected. That's why this behavior is affected. Okay? But of course, as I said, they put protection on that. They did filter out. Okay? And that's why this environment variable actually why affect the loader and the linker. Why it affect? That's exactly. The code is a code. Inside the code, it will look for these two variables. It looks for these two variables. And use these two variables to identify where the libraries is. And then do the linking. Okay? It depends on that. Okay? So that's why now if the UID and the effective user ID is different from the real UID, they will not trust the environment variable that you provided, and they're going to use their own. Okay, so that's what happens here. Okay, so that's no magic. Anytime when the environment variable is affected somewhere in your code, whether it's written by you or not, and environment variable is used. Okay, it's not going to magically affect you. Here's a very simple function. Did I use any environment variable? Okay, will the environment variable affect me?
Yes.
Okay, from where?
Printf, it needs linking.
Okay, let's take that away. Okay, we actually have a taking care of that. Okay, the library part. Okay, whereas so that's a good point. Okay, so let's just say we have resolved that. The linker part. Is there any place where library the environment variable might be used? Get text. Okay, so this is a library function, right? This library function may use the environment variable or may not. Most of them they don't. Okay, but this one turns out this get text, and they usually for translate into the different language. When you write application, depending on your region and depending on your locale, okay. And you will actually fetch the use a different database and find the actual text for that particular language. So if the language is set to Chinese, when you get text, okay, and it will look for the Chinese character, okay, and then the Chinese character will be printed out, okay. And if it's different language, and that's what the get text does, okay. It really get the translation. They don't translate that, okay. They just use this as index, and you have to provide the translate the text. Okay, this get text doesn't translate for you. It's really just you provide it with the key, then we give you that actually the string. Okay, you have to provide in that file. Okay, so now this file is decided by an environment variable. Okay, which file that can be used is actually decided by the environment variable. Now, if you can change that file, okay, if this program always uses system file, they're supposed to use system file. But looking for the file depends on the environment variable. Okay. Now, if you can change the environment variable and you can kind of provide your own file, you can provide your own output. So this will print out something else. Okay. And you may think this is not a big deal. Okay. And once we learned about the format string, okay, we will talk about format string. So how can you mess up this format string and to actually to compromise this program? Okay, so if you can control the text and you can take advantage of that vulnerability, and you should be able to gain the privilege from here. Okay, so when we get there, and you will see. Okay, but right now this get text and use the environment variable. Okay. So here I'm using the get env. So clearly I have a environment variable. I have attack surface, right? When you inside of your shell, okay, when you type cd something, cd is a built-in shell command. Okay, whenever you type cd, the shell is gonna update PW environment variable, not environment variable. I keep saying environment variable, and update the shell variable. Okay, and the CD basically is going to keep updating the shell variable. Okay, and so now, of course, when the shell runs a program, this shell variable becomes environment variable. Okay, so when inside of this program, I'm trying to get env from the PWD. Okay, and then I'm copy this to a buffer. Okay, so what's my attack surface here? Do I have a control of PWD? Remember, this PWD is set by every time I run CD, shell is going to actually set its environment variable for me. Okay, so when I then type another command to run a command, this shell variable is going to become the environment variable of the new process. Okay, so now if I have a control of this value, I can make this very large. Right now I'm doing a copy, right? The size of this array is going to be 64 bytes. If I can make this large enough, I can override that buffer. Okay, and from the next lecture, you're gonna know if you can overflow the buffer, you're gonna gain the privilege. Okay, we're gonna learn how. But the question here, in order for me to use the buffer flow attack, I need to be able to create a buffer overflow. But currently, this PWD, the current folder, is not going to be that long. Even if it's long, the content of that is just the folder name, which I cannot easily use to actually launch the buffer overflow attack. Okay. Remember, this is a shell variable turned into environment variable. So while you are in a parent, can you control this shell variable? Yes, you can. It's a shell variable. You should be able to control, right? Although the shell automatically update that, but I'm not gonna let the shell to update as long as I don't execute CD. Okay, so that's what I did. I type the PWD. Okay, I go to this folder and I echo PWD, shell variable. I get this value, which is my current folder. That's right. Now I cd dot dot. I echo this again. I go to this one. That's right. Okay, that's how the PWD works. Because every time I run CD, it actually updates my PWD. Now, what if I now go to CD / I echo this? I get this here. Now I'm just directly modify PWD equal to XYZ. And I don't run CD again. I know if I run CD again, PWD is going to be equal to my current folder. But I'm not running that. And I run PWD. I'm in the root folder. I echo PWD. What do I get? I get XYZ. My current folder and my value is different. That means I can control whatever goes inside. So instead of using XYZ, I can let PWD equal to a very, very long string. Then I will run that code. I will run this code. Okay. At this point, that's going to be our bus overflow. Okay. So you can see this one is I'm using an environment variable, but you may think that a user may not have a control of PW. You think that PW is controlled by the bash, but you own that bash. Okay. So and you can modify that. Okay. So how in your code, if you want to get env, you can use get env to do that. Okay. But you should use a secure get env in your privileged code. Always use secure get env, not using get env. What secure get env does is normally it's the same as get env. If the real user ID, real RUID, and the EUID is the same, these two functions are the same. Okay? If RUID doesn't equal to EUID, and secure get env get empty set. Okay? So you won't be able to return anything. That's for protection, because anything in the environment variable is untrusted when in the setuid program, because setuid program is launched by the real user, right? That's the real UID, but it has the effect UID privilege. Okay, so when this happens, then the environment variable set by the real user ID cannot be used. Okay, cannot be used. So in my code, I just called secure get env to make sure if my code runs in that kind of condition, I will not be affected by the environment variable. Okay, in my code, I can only control my code. Okay, so I'm still subject to the system things. If I run the system, I will be subject to that. Then the library things is all going to subject to that.